Hi everyone, welcome back to Fat Cat Maths. This week we're going to be looking at trigonometric graphs. This is one of those topics in GCSE maths that looks and sounds really confusing and difficult. But the majority of this topic is actually just learning how to draw three different graphs. These graphs are called sin, cos and tan, and what's great about them is that they're all drawn on top of the same x and y axes. To draw any of your graphs, label your y-axis 1 and -1. Then label your x-axis by going up in 90 degrees. Do the opposite on the other side for your negative x values. Sometimes examiners might give you the graph paper with the x and y axes already filled in, but if they don't, this is what you need to write for any of the three graphs. Now that we've drawn in our axes, let's start by learning how to draw the sin graph. Sin always starts at 0. It never goes higher than 1 and never goes lower than -1, but every 90 degrees it alternates its position like a wave. It goes from 0 up to 1, down to 0 again, down to -1 and back up to 0. You can then continue this pattern on the other side. Technically, these graphs go on forever, so there isn't actually an end point. But normally we do them from -360 to 360, and in your exam question they'll make it clear where they want you to start and stop. Okay, and that's sin. So next up, let's try drawing cos. This is really similar to sin, except it starts at 1. It's the same in that it doesn't go above 1 or below -1, and every 90 degrees it changes its position like a wave. Just like with before, you want to continue this wave on the opposite side of the y-axis as well. Great, so let's just have a quick recap of sin and cos. Sin starts at 0, never goes higher than 1 or below -1, and every 90 degrees it changes its position like a wave. Cos is almost exactly the same, but it starts at 1. When they're drawn together like this, you can see just how similar they are. If you remember how to draw one, you can draw the other by shifting it to the left. Drawing tan is slightly different, but notice how it starts at 0, just like sin. A little way to remember is that the only word that has an O in it, which is cos, is the one that doesn't start at 0. It would be nice if it was the other way round, but hey-ho, still a good memory jog. From its starting point, tan sort of makes this unusual shape in which it goes up on one side and down on the other. This same shape repeats every 180 degrees. Notice how, unlike with the first two graphs, the tan graph does go up past 1 and down past -1. As long as you're showing that it goes past these two numbers, it doesn't really matter where you show that it stops, but make sure that it never hits the 90 degrees before or the 90 degrees after it. Technically for tan graphs, these lines continue up and down forever, always getting as close as possible to the 90 degrees in front or behind it, but never touching. Okay, so now that we know how to do tan, we know how to draw the three trigonometric graphs. And like I said before, it really does make up the majority of this topic. Here's a quick recap. All three graphs start on the same graph paper, with a 1 and a -1 on your y-axis, and your x-axis going up in 90 degrees. Sin and tan both start at 0. The only one that doesn't start at 0 and starts at 1 is the one with an O in its name, which is cos. After starting at 0, sin never goes above 1 and never goes below -1, but it does change its position every 90 degrees. After starting at 1, cos never goes above 1 or below -1, but again it does change its position every 90 degrees. Sin and cos both look like waves that continuously move through the graph. To draw tan, we start at 0 and make this curved shape. We repeat the shape every 180 degrees. It goes past 1 and past -1, but never hits the imaginary line at the 90 degrees before and 90 degrees after it. So, now that you know how to draw them, what kind of questions could you get in the exam? One of the most common types of questions is actually just to draw one of the graphs that we've learned how to do today. The only thing is that they'll probably ask the question like this. Sketch the graph y equals sin brackets x. It means the exact same thing as asking you to simply draw the sin graph, and if they want you to do the cos or the tan, they'll replace the word with cos or tan. The only other type of question that they could ask on this topic is to solve an equation, and this really doesn't involve much more than what we've already done. All you have to do is draw the graph that they've asked you about. They've asked us about sin, so I'm going to draw my sin graph. And then take a ruler and draw a line straight through your wave at the number that they've asked you to solve. They've asked us to solve sin x equals 0.5. So I'm going to find 0.5 on my y-axis and draw a line straight across. What they actually mean when they ask us to solve this equation is to find all of the points where the line that we just drew goes through the sin graph. Remember that technically these graphs actually go on forever, so unless we were told where to start and stop, there would be an infinite number of places where the line that we just drew intercepted our sin graph. For that reason, they'll normally tell you where to start and stop. Here, we need to look for all of the points where the line goes through the sin graph between minus 360 and 360. We can see on the graph that there are 4 points where the lines intercept, and to calculate the first one just requires a calculator. Type in the number that you've been asked to solve with Shift Sin. If I do that onto my calculator, I get 30 degrees. So 30 degrees must be this point here where the line intercepts my sin curve. To find the second point of interception, we can utilise the fact that there is a line of symmetry at 90 degrees. This means that if I do 180 take away the first answer, I'll know exactly what that second point of interception is. Lastly, because all of the points repeat every 360 degrees, I can take each of my answers, take 360 from them, and get my next two answers. 150 take away 360 is going to get me minus 210, so that's going to be my third point of interception. And lastly, 30 degrees take away 360 will get me my final point of interception of minus 330 degrees. It's important to note here that on your cos graph, you have a slightly different line of symmetry because it starts at 1, not 0. This means that after you put the shift and the cos button in with the number that they've asked you to solve, you're going to find your second point of interception by taking your first point away from 0. This will give you the two middle points of your cos graph, and then you can add 360 degrees to one of them and take 360 degrees away from the other to find the rest of your points. For your tan graph, it's even easier because it just repeats every 180. So add 180 to the first point you get and just keep going up or down until you reach the parameters that they've given you. Okay, that is it. Well done. Let's have a quick look at the summary. This entire topic revolves around just being able to draw 3 different graphs. All 3 graphs start on the same type of graph paper, where you have a 1 and a minus 1 on your y-axis, and then you go up in 90-degree intervals for your x-axis, and then the opposite in the minus figures on the other side. Your sin and tan graphs both start at 0, whereas cos starts at 1. Sin and cos work like waves, where they never go higher than 1 or lower than minus 1, but they do change their position every 180 degrees like a wave. Tan is the one that doesn't look like a wave and goes further than 1 and lower than minus 1. It will keep going in this unusual looking shape, but never reaches the 90 degrees before or behind it. It gets as close as possible, but never touches it. Apart from being asked to draw one of the graphs, you might be asked to solve it, and in this case, you just draw a line across the y-axis at the point that they've asked you to solve. This will give you points of intersection between the graphs and the line that you've just drawn. You can find out what the first point of intersection is by putting in Shift, either your Sin, Cos and Tan button, along with the number that they've asked you to solve. From there, you'll be able to find the other points of intersection by using the line of symmetry and the fact that each of the graphs repeat every 180 or 360 degrees. Okay, and that is the end of the video. Well done, everybody. I know that this topic isn't easy. I try and simplify it as much as possible, but it's still quite a difficult one. So please feel free to ask any questions that you might have in the comments and take a look at the other videos that are out there. Thank you very much for your time. I really appreciate you listening, and I will see you next week. Thank you. Bye.